Unit 5, Learning Target 2D. I can solve a system of three variable equations algebraically. So we start with three equations. With systems of equations, you must have one equation for every variable. We have three variables. We have x, y, and z. Therefore, we must have three equations. So our first equation, negative 4x minus y minus z equals negative 12. Our second equation, 6x plus 5y minus 3z equals 28. Our third equation, negative 3x minus 5y plus 2z equals negative 13. We need to find a variable that is easy to eliminate from two of the equations. So looking at the three equations given, I notice that equation 2 has a positive 5y, and equation 3 has a negative 5y. So I'm going to add row 2 plus row 3, or equation 2 plus equation 3. So literally, row 2, 6x plus 5y minus 3z equals 28. And equation 3, or row 3, negative 3x minus 5y plus 2z equals negative 13. I'm going to add these two equations together. 6x plus negative 3x is 3x. 5y minus 5y means that they cancel. Negative 3z plus 2z is negative z. And 28 plus negative 13 is 15. Notice that the y has been eliminated in that equation. Now I need to eliminate y again, because I need two equations where neither of them have a y. So this time, looking back at my three original equations, I notice that row 1 has a negative y. So if I multiplied row 1 by 5 and added it to row 2, I could eliminate y. So I'm going to do a row 2 plus 5 times row 1. So row 2 is 6x plus 5y minus 3z equals 28. And 5 times row 1. Okay, 5 times negative 4x, negative 20x. 5 times negative y, negative 5y. 5 times negative z, negative 5z, equals 5 times negative 12, negative 60. I add the two equations together. 6x plus negative 20x, negative 14x. 5y plus negative 5y cancels. Negative 3z plus negative 5z, negative 8z, and that equals 28 plus negative 60, which is negative 32. And again, the y has been eliminated. So I now have two equations that have a y and a z. So I'm going to solve for x by eliminating z with the two new equations. So my two new equations are 3x minus z equals 15 and negative 14x minus 8z equals negative 32. Now, using elimination, I notice that I do have a negative z and a negative 8z. So if I were to multiply the top equation by negative 8, I could then add that to the bottom equation. So negative 8 times that top equation. Negative 8 times 3x, negative 24x. Negative 8 times negative z is positive 8z. Negative 8 times 15 is a negative 120. I'm going to add that to that second equation. So negative 14x minus 24x, or plus a negative 24x, is negative 38x. The z's cancel out, and negative 32 plus negative 120 is a negative 152. Divide both sides by negative 38. X equals 4. Now my next step is to solve for z. I'm going to solve for z next because I do actually have two equations that only have an x and a z in them. So I will use substitution. I'm going to use the equation 3x minus z equals 15, but I'm going to substitute 4 in place of x. So 3 times 4 minus z equals 15. 3 times 4 is 12, minus z equals 15. Subtracting 12 from both sides, I have negative z equals 3. Dividing both sides by negative 1, z equals negative 3. So I now have both x and z. I need to find y. So I'm going to solve for y. To solve for y, I need to use one of the original 3 equations. It does not matter which one of the 3 I use. I have chosen to use the first one. So I'm going to substitute 4 in place of the x, and I'm going to substitute negative 3 in place of the z. So negative 4 times 4 minus y minus negative 3 equals negative 12. Of course, negative 4 times 4 is negative 16, minus y. Negative 3 is plus 3 equals negative 12. I do have a negative y. I combine like terms. Negative 16 plus 3 is negative 13. It's still equal to negative 12. I add 13 to both sides, and I get negative y equals 1. Divide both sides by negative 1, and y equals negative 1. I write my final answer as what we call an ordered triple, x, comma, y, comma, z, with parentheses around it. So x is 4, y is negative 1, z is negative 3. On my next example, my first equation is 6x plus y minus 2z equals negative 20. My second equation is negative x minus 6y minus 6z equals negative 19. My last equation is 2x plus 3y plus 2z equals 4. I am going to look at these equations, and I notice that in the first equation I have a negative 2z, and in the third equation I have a positive 2z. So if I add row 1 plus row 3, I can eliminate z very easily. So row 1, 6x plus y minus 2z equals negative 20, plus row 3, 2x plus 3y plus 2z equals 4. I'm going to add the two equations together. 6x plus 2x, 8x. Y plus 3y plus 4y. Negative 2z plus 2z cancels. Negative 20 plus 4, negative 16. I need to eliminate the z in another equation so that I have two equations that only have the x and y variable in them. I look at row 2, and I notice that row 2 has a negative 6z in it, and I notice that row 3 has a positive 2z in it. So I'm going to multiply row 3 by 3 and add that to row 2. So row 2, negative x minus 6y minus 6z equals negative 19. And 3 times row 3, 6x plus 9y plus 6z equals 12. Add together, 5x plus 3y, the z's cancel, equals negative 7. So I have eliminated the z from both equations. Now I need to eliminate y from the two new equations. So I have 8x plus 4y equals negative 16, and 5x plus 3y equals negative 7. Adding just by itself won't work, so I'm going to multiply the first equation by 3 and the second equation by negative 4. So my new first equation is 24x plus 12y equals negative 48. My new second equation is negative 20x minus 12y equals 28. I add them together, and I have a 4x equals negative 20. Solving by dividing by 4, x is equal to negative 5. Solve for y by substituting in for x. I'm going to use the 5x plus 3y equals negative 7 equation. 5 times negative 5 plus 3y equals negative 7. Negative 25 plus 3y equals negative 7. Add 25 to both sides, and I have 3y equals 18. Dividing both sides by 3, y equals 6. Again, using one of the original equations, and it does not matter which one, I substitute in both x and y to solve for z. I'm going to use the middle equation, so I have a negative 5 minus 6 times 6 minus 6z equals negative 19. So positive 5 minus 36 minus 6z equals negative 19. Negative 31 minus 6z equals negative 19. Add 31 to both sides, and I have a negative 6z equals 12. Dividing both sides by negative 6, z equals negative 2. And I write my answer as an ordered triple in parentheses with commas between them in alphabetical order x, y, z. So negative 5, comma, 6, comma, negative 2 in parentheses.